Let's say there's an asteroid threat looming over us. What can we do about it? We may encounter a situation in the future where our planet, and possibly even an off-world colony, like Mars, is under threat from a large asteroid. However, we are in a position to do something about it. Planetary Defense. As nations argue over stupid issues and territoriality, there is already a very active international planetary defense scene. Both government and independent organizations around the world spend their time looking for potentially hazardous objects, share data with one another, and think of ways we could stop them if they ever decide to pay us a visit. This brings us to our first line of defense: catalog and track. Both ground and space-based projects actively search for and track all kinds of objects: small asteroids, big asteroids, comets, centaurs, and even rocket upper stages. The ones that are of interest here are the large near-Earth objects, or NEOs. Large asteroids that cross the orbit of Earth are very important to track and monitor. Although the chances of an impact are low, it's still very important to find as many of these as we can. Learning about asteroids and comets is also a very important aspect of planetary defense, know your enemy kind of situation. Missions like OSIRIS-REx, Hayabusa, Deep Impact, and Rosetta have all been very valuable to this end. Now, let's say we do discover a large object on its way to Earth. What can we do about it? There are actually many options for active defense. Which one we use depends on many factors regarding the size, composition, and physical properties of the object. Kinetic Impact. One way to deflect an asteroid and assert dominance over the solar system is to respond the same way we tend to respond to any threats, by hitting it. A spacecraft can be sent to physically ram the offending asteroid, the kinetic energy and resulting ejecta from the impact changing the asteroid's orbit by a very small amount. Over the years between impact and potential collision, that small change will add up, causing the asteroid to miss the Earth completely. Depending on the size of the asteroid, a single impactor or a series of them can be used to impart small orbital changes. This method would be best used against solid asteroids like iron-rich or solid rocky ones. By exposing the inner layers, the sun's heating could also cause volatiles like ice to sublimate, the dust and gas blowing off imparting a small force, further aiding in the deflection. Nuclear standoff. One thing movies have shown us is you can always drop a nuke on an asteroid to save the day. This isn't very accurate, but there are nuclear methods. The nuclear standoff method requires a nuclear warhead to be detonated next to the offending asteroid, instead of directly trying to blow it up, which could result in a shower of smaller meteors still causing massive damage. This method uses the nuclear detonation itself to push the asteroid or comet, changing its orbit. The detonation can also be used to superheat one surface, making the asteroid change direction from off-gassing. A similar approach is to use a kinetic impactor to make a crater on the asteroid in which the bomb is then placed, acting like a nozzle directing more of the energy into the asteroid, deflecting it more. Multiple bombs can be used over the course of a few hours, pushing the asteroid like an Orion drive. This method would work well against most types of asteroids and even comets. However, it could be risky to use against rubble pile asteroids. Instead of deflecting it, we could end up breaking it up. Gravity tractor. A less aggressive method to move asteroids out of the way is to use a gravity tractor. A small spacecraft would intercept the asteroid and enter a halo orbit around the asteroid in the direction you want to move it. As the spacecraft uses its ion engines to maintain its altitude, the gravitational attraction between the spacecraft and asteroid, although very small, would cause the asteroid to slowly be pulled towards the spacecraft. This would require years of advance notice, but the force is so small it could be used to move even the most fragile of objects. A related concept is known as ion beam shepherd. In this case, the vehicle aims its ion thrusters directly at the asteroid and uses the momentum of the ions themselves to impart a pushing force. This would also take years, but would be completely safe to use against rubble piles. Directed energy. Asteroids, and especially comets, can be used to move themselves out of the way. One such approach is to use a sci-fi favorite technology, asteroid laser ablation. A spacecraft would position itself close by and shoot a laser at the offending object. Heating up a small point on its surface, it would cause material to vaporize off, producing a jet that acts like a thruster. A similar approach is to use a large parabolic mirror or array of lenses to focus solar energy onto the object like a magnifying glass, resulting in the same effect with less energy required. These methods would work very well against comets and rocky asteroids. Use the sun. If we want to use a more hands-off approach, we can also always use the sun. By this, I mean alter the surface characteristics of the asteroid as to impart a force due to the sun's influence. One way is to lighten the object by painting or dusting it with a white coating of titanium dioxide. This would change the reflectivity and solar pressure would become more prominent on the asteroid. A similar method is to wrap it in a highly reflective film, making it like a solar sail. A third approach is to paint the asteroid a deep black. This would cause the asteroid to heat up and emit thermal photons, imparting a force through the Yarkovsky effect. Direct thrust. A more Hollywood approach is to directly land a vehicle on the asteroid itself and make it impart a direct thrust. A chemical engine is not very practical, so the engines in question would probably be ion or plasma based. If you don't want to use fuel at all, you can always drop a mass driver onto the surface. Once landed, the spacecraft would start digging into the asteroid and launching material off. This would impart a force similar to that of using an engine, only there is no fuel, just an electric miner shooting rubble off the surface. Other approaches. There are many lesser explored proposals that could be used, such as spraying clouds of steam in the path of the asteroid, slightly slowing it through friction, or attaching a counterweight on a long tether to the asteroid, thus changing its center of mass. A more extreme version of the steam proposal is to move a comet into the path of the asteroid and vaporize it with a nuclear bomb, creating a temporary fake atmosphere cloud to slow the asteroid. For iron-rich asteroids, a huge coil could be placed in the path of the asteroid, generating an electromagnetic field. The field would cause inductance in the asteroid, impacting its course. Earth is a very valuable planet, being our homeworld and all, so it makes sense that we've been putting a lot of time and effort into thinking about ways we can prevent ourselves from being destroyed by a wayward rock. At the time of this recording, a planetary defense mission is currently on its way to the asteroid Didymos to slam into its moon, Dimorphos. This is a small-scale test of the kinetic impactor method. In a very real sense, we're about to shoot an asteroid in the face. Another way to look at the DART mission is it's not just a planetary defense test, it's humanity showing we won't let rocks get the better of us. We are starting to bring the fight to them, and are avenging the dinosaurs.